Today we are going to learn the energy balance in vacuum tower. So as we know that there are two types of tower, one is a loop based tower, one is fuel based tower. So we are going to learn the energy balance for one case in the loop based and one case for the fuel type tower. So as far as the energy balance concept is concerned, the energy balance concept is same as in the case of the atmospheric distillation column, and probably you remember that in the atmospheric distillation column we have discussed
So
all
in
these
this
things.
lecture, we'll discuss about how to carry out the energy balance to distillation column. That this is the example or the now balance, that is a residue, bottom residue is plates are FW, heat as QW. After knowing get our object inside, F is use nothing but Q column up to the distillate D1.
So to understand the basic concepts, you can better to go and learn in the previous lecture. Here we are just going to give the idea about how to carry out the energy balances. So now see here, energy balance in the loop type tower. So we are taking the one example in the loop type tower, and that example is related with the pump bag reflux. So this is a diagram for the pump bag reflux. So how we can do, we can take one by one step. For example, first we have to go for the energy balance up to the flash zone level. Let us take a zoom. Now this is a flash zone. You see that this is a steam, bottom is steam, air leakage. We have discussed all these things. This is a feed. So all these are going inside the column. So we can say energy in, and the leaving energy is the bottom residue. And so we can say the energy inlet up to the flash zone is nothing but the QF plus QA plus QSW. That is the energy inside the column, and the energy outside from the flash zone is only the QW. This is energy. So the difference between these two energy that is moving within the column, this delta Q FZ is nothing but the energy in minus energy out of the flash zone. So in this way we can find out the energy balance for the flash zone section. Now come to the next envelope, that is the next section up to the D1. So for that you can go for up to the first product, that is a over flash is taken as a product. So we can say up to the first product. So up to this energy balance can be possible, and it is very easy to understand. All the material that going inside is only the energy up to the inlet of the flash zone, means there is no new streams that is going inside up to the overflash product. And now come to the energy out. So energy out, because of this liquid material, the amount QL0 is the amount of energy that is associated with this L0, and that is leaving from the column. So we can say that all the energy leaving up to the flash zone plus QL0. So this is the energy out for Q dash IGO and Q dash OGO. You can say grid outlet. GO is for the first one, that is product from the vacuum distillation column, slope oil, you can say, condensed oil, you can say. So the difference between these two values gives the delta Q dash GO. So in this way we can find out the energy amount of energy up to the L0, that is the condensed oil. Now come to the product D1, energy balance up to the product D1. So see all the inlet streams. So I think there are only one inlet stream up to this section, that is a S1. Due to S1 there is an energy amount QS1. So in the inlet, all the energy inlet up to the previous case, that is a Q dash IGO plus this is the amount of energy that is going inside for this section QS1 steam. So this is the total amount of the energy that is going inside at Q dash I D1 up to the distillate. Leaving the energy up to the D1 is only D1, that is energy associated with D1 is a QD1. This is the amount of energy that is leaving. And also if you look here, this is a QC1. This is the condenser where we are condensing a portion of the basically material for the reflux bag. So this amount is also leaving. So we can say that QC1 and QD1, these are two more streams apart from the Q dash OGO, that is apart from the previous outlet of energies. This is a total amount of energy leaving up to the D1 section, that is the Q dash D1. So we can say that the difference between inlet and outlet is Q delta Q dash D1. This is the amount of energy, difference amount of energy that is leaving inside the column and going upward sections. Similarly, we can go for the energy balance up to the D2. So very simple, the only stream that is going inside is S2, so you have to add that informations here, S2, and there are two energy that is leaving from, one is D2, so QD2 energy content, one is QC2, that is the condenser. So you can add in the leaving portion, in the leaving section, and then again calculate the delta Q dash D2. So in this way you can find out for the D3 the same case. S3 is going inside and D3 and QC3, these are the two streams leaving. You have to incorporate all these two values at their respective sections, inlet and outlet, and then you can find out these values. For the D4 you can also put the same equations, but this is not available here, so you don't need to put that one. Up to D3 you can write all these external heat quantities, so that we can find out the amount of energy, that is delta Q dash, that is going upward section within the column. This is the way to find out the energy balance. Similarly, we can go for the energy balance for the fuel type tower. In the fuel type tower, we can use the pump around heat removal with fluxes. This is the diagram. It's a very simple one where bottom residue is one product, and then we have a L0 as a product, D1 as a product, and D2 as a product, and at the top obviously that is basically the vacuum maintenance, but very small fraction of hydrocarbons are also present there. We are not concerned about one, but that one. So in this case also you have to first up to the flash zone, so air leakage, steam, bottom steam SW, that is QSW, QA, and feed QF. These are the three values that have the energy going inside the column, and only the QW is leaving section. So delta IFZ, that is the amount of energy going inside the flash zone, and Q dash OFZ, the amount of energy that is leaving the flash zone. And this is a difference. You have to make the difference value in minus out, that gives the amount of energy that is flowing inside the column. Similarly, up to the L0, sorry, up to the L0, this is the expression for up to the L0, and for the up to the D1, this is the expression for up to the D1, because up to the D1 two things are leaving, QC1 and QD1. These two things are leaving. There is no basically refluxes, strippers are there, so there is no S1 stream are there. So that is a difference in this one. It is a very easy thing to carry out the expressions for the energy balances in all these equations. So this is all about the energy balances in a fuel type tower. Thank you very much.